Section 1.2, functions and their properties. This is like the most important section of the year.
Basically, what she said.
Okay, starting off, a blank is a set of pairs of input and output values.
Coordinates.
No, relation.
Oh.
A relation.
Like
a relationship.
Because there's two of them.
Because there's, it's a relation is something that puts these values with these values in like an organized way.
Right.
They can be represented in numerous ways. You can do ordered pairs, like a list of ordered pairs. You'd use a squiggly bracket at the beginning of that.
Okay.
And we could just have like
a fancy bracket. Those are what the squigglies are called.
You just could have like some random set of ordered pairs or whatever, like this.
Wow, that's a bunch of ordered pairs.
Or I'm gonna do one more. We could have like maybe this. Okay.
Ooh.
Okay. So
some ordered pairs.
So write down those examples of ordered pairs.
No rules, just right.
Right. Input output table would be like your XY table.
T charts or things of that sort of nature.
And they can be vertical
or horizontal. By the way, we don't know what these graph. These are just we're just making
picking
these
stuff up.
Yep.
Yeah. Straight from my mind into the pin, through the cord into the computer.
Instantaneously, almost.
Almost.
So there you go. There's input output table. You put the X in.
Jot that down.
You put the X in. You get the Y out.
Hey, that sounds like a song. Okay, a coordinate plane. It could actually be just like an X and a Y, and then you could have like some random points.
Hey, those random points are linear.
Those are, that is kind of a linear fashion. Or you could actually have a graph. And so maybe your graph looks like these.
Hey, that looks like a quadratic.
That does look like a quadratic. That's totally what I was going for. Or you could have a graph maybe that looks like this.
That looks like a conic section.
Okay, well, like a circle or an ellipse.
Yeah.
Okay. And then mapping diagram is the one that we'll see the least and has more application in like super obscure levels of higher math, but
she would know.
Yeah, you've got two circles, an input and an output circle, and you have numbers in each.
And they just draw a line into the output circle draws to the input draws to the output. So there you go. That means 1 goes with 4, 2 goes with 4, and 3 goes with 5.
Right.
Yeah.
Okay, so
all right.
Now that we've got all these different ways of representing relations, there are specific kind of relations that we really care about.
Okay.
And they are called functions.
You know what? We're going to study functions pretty much until we study conic sections.
And then they're not functions, they're relations.
Those aren't. Those are just relations.
A function is a relation where every input has exactly one output. That means if you put in a number, you only get one answer. You don't get more than one answer.
You can't get more than one answer. So if I put 1 in, I'll get a 2.
Or whatever it is.
Or a 3. But if I put a 1 in and get a 2, and then I put a 1 in and get a -2, no deal.
Right.
That is not a function.
That's not a function. So on this first example, we're actually going to determine which of these above, which is why there's multiple examples up here, we're going to determine which of these are functions, and then also we're going to look at these 2 equations down here.
Okay, let's do it.
So when we're looking at ordered pairs, what matters is that if each input has one output, my x values better not repeat.
Yeah, you can't have any x values over and over again. That's no deal.
So this first one, 1, 2, 4, we're fine. It didn't
Sounds
repeat,
good.
so that's a function. Okay, but for this second one, 0,
zero
has
is,
2 different things for y values.
It could
so
be
that's
1 or
not.
3, so that's no deal.
Absolutely. For our input and output table, again, we really just care about our x values. All of our x values are different here. It doesn't matter that our y's are the same. This is a function.
That's a function there. The other one is not, because -3 gets used more than once.
And goes to different things.
And it goes to different numbers. Now, if you had -3 go to 5 or -3 go to 9 several times, that's different, because that's an individual
like
point.
if I had made this a 5,
right.
That's just the same point repeated. So that would have been fine. On the coordinate plane, we have a special test that we do, and I'll write it up here.
Vertical line test.
Yes, a vertical line.
It's quite handy.
Is the line that goes up and down. And
Vertically.
Yes, the vertical line test says that if I draw a line anywhere on my graph, as long as it goes through the graph once, then it's a function. If anywhere it would go through more than once, I've got a problem.
Yes.
So because these points are all lined up differently, this would be a function. Like if I had a point right on top of each other, like another point here.
Well, that looks danger.
Yeah, that wouldn't work. Okay, but for these actual graphs here now,
That's
like,
a function. Quadratics are functions.
Yep, because it only goes through once no matter where I draw it. But
That's
here,
not a function.
That's not a function.
Because notice it's going to cross that circle. Now, Mrs. Stevenson could have drawn her line way over on. Draw a line right there on one of those. Yes, right there.
I
now,
could draw a line
now,
there.
It only goes through once. But we have to be able to draw that line anywhere on that graph.
Anywhere
on that graph, and
Right.
only touch it once.
Right. So that's the vertical line test, which that should seem familiar,
Right.
I believe. Mapping diagram, you're looking for each input needs to go to only one thing. So this is a function because all the arrows are good. But if we had, I'm going to go with like a simple scenario here. If this one was going to all of these things, that's not a function.
Bad. That's bad.
That's bad.
All right.
So how can we tell just from looking at equations? Because we could graph these.
We could graph those.
Especially this first one, a square root graph. I don't know exactly where it is off the top of my head, but I feel like it's something like this.
Yes, I would agree that.
So vertical line testing that would prove that this is a function.
Right.
Okay, but what actually happens is there's only two cases that I know of that really screw with us as far as function or not a function, and that's y squared or absolute value of y.
Okay, sounds good to me.
Because,
so don't screw with those.
Because if I try to put this in my calculator, I have to solve for y.
Right.
So I got to subtract x squared over
Yep.
y squared equals 9 minus x squared.
And then when you take the square root of both sides,
You know what you gotta do?
You got to have plus or minus the square root.
You gotta.
And now that tells us that y could be two different things.
Right.
And that's
what we mean by you put in an input to x, but you get two answers out.
Right. That's no deal.
That's not a function.
Yeah. So anytime you have y squared or absolute value, and pretty much really that is the only sort
Those
of
are the only two I can
situations.
think of.
Yeah.
If you see those situations,
Run
like
away.
absolute value of x is fine.
Right.
But in both of those cases, think, how do I put that in my calculator? And when you're like, ooh, that's rough.
Or think, how do I get y to be all alone?
Yeah, how do I get y to be alone? Especially the absolute value, that's
Right.
tricky.
Yeah, because that's
We
negative
don't really
y, positive y.
Yeah, we don't talk about that a whole lot usually. And actually, I thought of another example. X equals any kind of number is a vertical line. And that
Oh
wouldn't
yeah,
be
that's not a function
either.
either. Okay, yeah.
So there's our non-functions.
Okay.